Hello everyone. Today our topic of discussion is complex matrix. What is complex matrix? A matrix is called a complex matrix if at least one entry of the matrix is a complex number. For example, A equals to 2i, 4 minus 3i, 9 and 7. First of all, we must know that what is complex number. A number which contains iota in itself is called a complex number. So, in this example, in matrix A equals to, in first row you can see that two entries containing iota. Therefore, this is a complex matrix. What is conjugate of a matrix? The matrix obtained from any given matrix A after replacing its elements by the corresponding conjugate complex numbers is called the conjugate of A, and it is denoted by A bar. What is conjugate complex number? If we have a complex number alpha plus iota beta, then its conjugate will be alpha minus iota beta. And if we have a complex number alpha minus iota beta, then its conjugate will be alpha plus iota beta. So, to find the conjugate of a matrix, we have to replace the complex numbers by its conjugate numbers. For example, A equals to 1 plus 2 iota, 2 minus 3 iota, 8 and 7. Then A bar, that means conjugate of matrix A will be 1 minus 2 iota, 2 plus 3 iota, 8 and 7. In this matrix, 1 minus 2 iota is the conjugate of complex number 1 plus 2 iota. And 2 plus 3 iota is the conjugate of complex number 2 minus 3 iota. But two real numbers 8 and 7 are same because we know that the conjugate of real numbers is same. Conjugate transpose of a matrix. Conjugate of a transpose is denoted as A star. That means if we find conjugate of matrix and we transpose that matrix, then the resulting matrix is called conjugate transpose of a matrix and it is denoted by A star. For example, A equals to 1 plus 2 iota, 2 minus 3 iota, 4 minus 5 iota, 5 plus 6 iota. So to find out A star, we have to operate two operations on this matrix A. First of all, we will find out conjugate of this matrix A and then we will transpose that matrix. By this way, we can find A star. In transpose of a matrix, we change rows by columns. That means rows becomes column and column becomes rows. So to find out A star in this example, first of all, we will find out conjugate of matrix A. That will be 1 minus 2 iota, 2 plus 3 iota, 4 plus 5 iota and 5 minus 6 iota. After that, we will transpose that matrix and we will get A star. Therefore, A star will be 1 minus 2 iota, 4 plus 5 iota, 2 plus 3 iota, 5 minus 6 iota. What is Hermitian matrix? A square matrix A is called Hermitian matrix if A star equals to A. So, to prove that given matrix is Hermitian, first of all, we will find out A star. Then we will see that A star equals to A. Then we can say that given matrix is Hermitian matrix. For example, A equals to 5, 2 plus iota, minus 3 iota, 2 minus iota, minus 3, 1 minus iota, 3 iota, 1 plus iota, 0 is example of Hermitian matrix. If we find A star in this matrix, then we will see that A star equals to A. Therefore, this matrix is a Hermitian matrix. Skew Hermitian matrix. A square matrix A is called skew Hermitian matrix if A star is equals to minus A. For example, A equals to 3 iota, 1 plus iota, 7, minus 1 plus iota, 0, minus 2 minus iota, minus 7, 2 minus iota, minus iota is a skew Hermitian matrix. To find that or to show that this matrix is a skew Hermitian, first of all we will find A star by finding conjugate of matrix A first, then by transposing that conjugate matrix. By this way we will find A star and we will see that A star is equals to minus A. Therefore, this is an example of skew Hermitian matrix. Now, fact is that every square matrix is expressible as the sum of a Hermitian matrix and a skew Hermitian matrix. In this fact, we are saying that if a given matrix is square, then it can be expressed as the sum of a Hermitian matrix and a skew Hermitian matrix. Following is an example of this. Express the matrix A equals to this in a sum as a sum of Hermitian matrix and a skew Hermitian matrix. This matrix is a square matrix, therefore this matrix can be expressed in as the sum of a Hermitian matrix and a skew Hermitian matrix. What is unitary matrix? A square matrix A is called unitary matrix if A into A star is equals to I, which is identity matrix, is equals to A star into A. So to show that given matrix is unitary, we will find out A star first, then we will find the product of A and A star and A star A. And we will see that this resulting matrix is identity matrix. If it happens, then we say that given matrix is unitary matrix. Next, 1 upon root 3, 1 plus iota, 1 minus iota, minus 1 is an example of unitary matrix. First of all, we will find out A star by conjugating and transposing the matrix, and then we will find the product of A and A star, and we will see that the resulting matrix is an identity matrix. Therefore, this is an example of unitary matrix. Next example is under what condition the matrix A equals to alpha plus iota gamma minus beta plus iota delta, beta plus iota delta, and alpha minus iota gamma is unitary. If this matrix is unitary, then A into A star or A star into A will be identity matrix. So first of all, we will find out A star. Now, conjugate of this matrix A will be alpha minus iota gamma, which is the conjugate of alpha plus iota gamma, minus beta minus iota delta, which is the conjugate of minus beta plus iota delta, beta minus iota delta, which is the conjugate of beta plus iota delta, and alpha plus iota gamma, which is the conjugate of alpha minus iota gamma. Now, A star will be the transpose matrix of that conjugate matrix. In transpose matrix, the rows become column and columns become rows. Therefore, A star is equals to alpha minus iota gamma, beta minus iota delta, minus beta minus iota delta, alpha plus iota gamma. For a square matrix, A to be unitary matrix, we must have A into A star equals to I equals to A star into A. Now, we will find out A star into A, that is a product of two matrices, and the resulting matrix become alpha square plus beta square plus gamma square plus delta square 0 0 alpha square plus beta square plus gamma square plus delta square, and A into A star will be alpha square plus beta square plus gamma square plus delta square 0 0 alpha square plus beta square plus gamma square plus delta square. We can see that A star into A and A into A star are same. So to these matrix, if given matrix A is unitary, then A star into A should be unitary should be identity matrix, and A into A star is also should identity matrix. Therefore, to have A be a unitary matrix, we must have alpha square plus beta square plus gamma square plus delta square equals to 1. If we have this condition, then A star A will be a identity matrix, and A into A star will also be a identity matrix. By this way, we can find out a given matrix is unitary matrix. Thank you.